Um, so I'll be talking about something called the modeling and simulation driven maritime marine spatial planning. This presentation will be covered under these ambits. I'll introduce my abstract. I'll give a little bit of a background context. I'll tell you what the problem with with marine spatial planning is. I'll tell you where my intervention comes in. I'll explain it, and I'll do a little bit of a stakeholder analysis. Right. So as far as my abstract is concerned, what I am basically looking at is that traditional marine spatial planning, it is largely descriptive in nature and it is very governance oriented. All that, sure, it exists. But the problem is that it is not able to forecast any kind of a planning consequence. Why? Because it heavily relies on existing data. It heavily relies on data which is very much static in nature. So what I'm attempting to do in my project, in my research, is to examine this critique, especially in the Indian context, largely because the Indian Ocean water, they are it's very much different from the Western waters. The place of origin of marine spatial planning has largely been the Western waters in the Western countries. So for instance, if you think of the ways in which the Pacific Ocean and the Indian Ocean, they're different, you have a lot of ways in which there is a lot of dynamic elements involved in the Indian Ocean that are not there in Pacific Ocean. Therefore, the argument is that this architecture of marine spatial planning is structurally not suited to India's monsoon-driven variability, ministry-level data fragmentation, and the absence of a unified MSP authority. And therefore, we must resort to something called the modeling and simulation-based MSP. To give you a little bit of a context, the Indian Ocean region, it faces two very complex issues. One is that it is highly variable when it comes to its oceanographic and atmospheric processes. So for instance, you think of the Indian Ocean dipole, you think of the Madden-Julian oscillation, the ways in which the temperature fluctuations happen in the Indian Ocean, particularly because it is situated in that part of the global sort of domain. And also, there is a lot of complex and geopolitical maritime activity. So you think of the epicenter, such as the Strait of Hormuz, the Strait of Malacca. With the Indian context, you have the Gulf of Khambat, the Gulf of Mannar, etc., etc. So it becomes a hot seat of a lot of complex geopolitical and trading activities, which are very dynamic in nature. Now, the existing literature that exists on MSP, which by the way is on traditional MSP, it comes with a whole lot of problems. So you have three major articles that I have looked at. One is an article by Ehler and Doover, the other is an article by Portman, and the third is an article by Grip and Blomquist. So Ehler and Doover, they're talking about a very integrated approach of marine spatial planning. Portman is giving a very step-by-step approach of marine spatial planning, and Grip and Blomquist, they're also giving their reviews on existing traditional marine spatial planning. But one common critique, which is, by the way, common to all of these papers and all of this research, is that it is highly dependent upon static and governance oriented data, a data which doesn't change over a period of time, but that doesn't and cannot suit the Indian Ocean. So four limitations occur across this. One is that all these conventional plans, they are built from static spatial data sets, and they represent a single point in time and not a period of time. And even though they might talk about species distribution, fish stocks, oceanographic conditions, one needs to understand that these are very inherently dynamic conditions. Second, traditional MSP, it can only identify existing conflicts among marine users and stakeholders. It cannot forecast long-term consequences of, let's say, upcoming conflicts or upcoming changes in the geomorphology, etc., etc. Third, sectors such as, let's say, fisheries or shipping or tourism, conservation, or let's say coastal infrastructure, these are very interconnected. These are very interconnected structures. These are very interconnected issues. They don't exist in isolation. And further in my presentation, I'll be talking about it, how they are very cumulative in nature. They're very interconnected in nature. This is something that traditional MSP cannot deal with, which is exactly why we need an MNS-based MSP. Lastly, conventional frameworks, they rely, like I told you about, on current observations, on expert judgment of static data, and not something which is dynamic in nature. And this, by the way, is not very theoretical in nature. It is very much grounded in reality. So, for instance, in Tamil Nadu, they had built up sea walls that were constructed to manage coastal erosion without any kind of modeling that was done on how sedimentation works and how sediment transport dynamics work. The result of it was that the entire erosion, it became downstream, and the fishing hamlets and the turtle nests, they were damaged. For instance, in Kerala, a $900 million infrastructure was totally stalled by a community because their views and their traditional knowledge, the indigenous knowledge that existed about them knowing about how things are forecasted, that wasn't taken into account. So they had to halt an entire $900 million infrastructure project. So you see, it's a tremendous waste of time and energy and resources, particularly for a developing country like India. Okay, now I'll explain how MNS-MSP works. It works through this five-channel situation. One, the first gateway that it crosses is real-time and historical data streams. So you think of oceanographic data, you think of biodiversity data, you think of human activity, you think of infrastructure. All these channels are taken care of. Second, it goes to simulation engines. So you model it, you simulate it. So for instance, you think of hydrodynamic simulation, agent-based simulation, climate projection, how climate will look like eventually, how an ecosystem will look like eventually. Third, it goes through impact analysis and scenario testing. So you can think of habitat risk management, you think of acoustic impact, you think of cumulative stress of all of these sort of areas together, you think of the conflict between different interest holders. Then it goes through decision support interface, where you have, let's say, the GIS dashboard, or for instance, you have policy tools that sort of help us in understanding and analyzing it. You have adaptive feedback. So whatever feedback comes in, you inculcate it into it. Finally, it comes into a simulation-based adaptive MSP plan, which is the final outcome of it, which is a very much of a living plan. It is continuously updated because the feedback that is coming in is also being updated. Therefore, it is very much in action. It is very much full of life. Okay, so there's this six initiative toolkit that I have brought in front of you. I won't go into individual depths, but I'll probably talk about, let's say, I'll talk about underwater noise mapping. So, what this six initiative toolkit essentially is, it is about the way the six different areas, especially where MNS based MSP can be used. So, for instance, for underwater noise mapping models, you have various sources of noise. So you have the wind, you have the rain, you have the shipping driven acoustic sort of contributions. All of these, they are mapped out in a cumulative stress map that supports seasonal climatology and the identification of acoustic quieter windows where sonars can be operated. Now, this wouldn't be possible if you're using traditional MSP, because it cannot predict how wind will flow. It cannot predict how rain will sort of, give its noise in the upcoming areas. So in order for you to have fully operational sonars, you require a prediction, you require a forecasting, where MNS based MSP comes handy. Lastly, I have the sectoral implementation and stakeholder analysis for you. What are the various places and areas and fields where you can possibly use this MNS based MSP? So you have fisheries and aquaculture, you have shipping, navigation, and port infrastructure, you have offshore renewable energy sitting, you have hydrocarbon and sea based mineral extraction, coastal and marine tourism, disaster risk reduction, marine conservation, and eventually we have maritime domain awareness, something that we all have been talking about. It's all very interconnected, it's all very sort of interlinked, and therefore MNS based MSP proves to be much more fruitful in helping us navigate and understand through this. That's all. Thank you for your time.